Another type of reaction is the single replacement reaction. In this case, something is being replaced. Something is doing the replacing, hence the term replacement. I'd like to take a look at the pattern here. What we've got is we've got an element and a compound. So if I can write this a little clearer. We've got as an element and a compound reacting. And what we get is a second compound and an element as our products. And we can have two different types of arrangements. In this case, the cation is getting replaced. There's my positive and my negative ion in my compound. The B element gets kicked out, so this would be a cation replacement. This top one is what is called a cation replacement because the cation gets replaced. This down here would be an anion replacement. And that's because in this case, here's my cation, here's my anion. The anion is the one that got replaced, that negative ion. All right, so let's take a look at this. One of my simplest analogies that I've heard over the years for this is something called the dance floor analogy, where it's considered cutting in. If you think about cutting in at a dance, you've got a couple dancing, and what happens is someone comes along and says, hey, mind if I cut in? And well, the person can either say, sure, you can cut in, and somebody leaves, and a new couple is formed, and they're dancing, and someone leaves. Hence, here's my new couple, and here's the person who leaves. So this cutting in analogy works quite nicely. The other option, though, is that someone can say, no, I don't want you to cut in, and the reaction or the new dance doesn't happen. In this case, the reaction doesn't happen. And the reaction doesn't necessarily have to happen. Single replacement reaction is governed by the activity series. What happens in an activity series is that an element can replace any element below it. So lithium can replace everything below it. Potassium can replace everything below it. Poor gold down here has nothing below it. Gold can't replace anything. There are two separate lists because there are two separate types of single replacement reactions. These are all cations. Excuse me. These are all anions. Cations can only replace cations. Anions can only replace anions. So fluorine can't replace anything over in this list. It just doesn't happen. Fluorine can only replace what's below it in this list. Two lists because of the two different types of replacements. There are a couple of things that occur in the cation list. From lithium down to magnesium, these can replace hydrogen in both acids and water. From aluminum on down to hydrogen, these guys can only replace hydrogen in acids. All right, let's take a look at a couple of examples here and see how this works. My first reaction, my first example here, I've got chlorine, an element, reacting with potassium bromide, a compound. I take a look at this. Chlorine is an anion, so chlorine's going to try to replace the anion from this compound. So I'm going to go over to the anion list, and I look at both chlorine. It's a little dark. I look at both chlorine and bromine. Now, chlorine can replace any element below it, and I look and I see that bromine is below chlorine, so chlorine can indeed replace bromine, so this reaction will happen, and what happens is bromine says, okay, you can dance with my date, I'm going to leave. Bromine winds up on its own, it's Br2 because it's a Hankelbrief, and we form a new compound, or a different compound, potassium bromide. A little sidebar here, potassium is a +1 charge. Excuse me, I said potassium bromide, I meant potassium chloride, because chloride's cutting in. Potassium chloride, hang on for a second, I got to get the phone. Oh, sales calls. All right, anyway, where was I? Oh, chloride, -1 charge, potassium chloride, so we get potassium KCl, because that'll add up to 0, just get one of each ion. I do need to balance this, so what I wind up with is a 2 here and a 2 here, because I've got 2 bromines now, 2 bromines, 2 potassiums, 2 potassiums, 2 chlorines, 2 chlorines, and I'm set. Take a look at another example. In this next example, I've got bromine reacting with hydrochloric acid. So in this case, again, I'm going to my anion list because bromine is an anion trying to replace an anion. So I take a look and I see chlorine here, bromine here. Bromine can only replace what's below it. The only thing below it is iodine. Chlorine, you can't kick out chlorine. Not going to happen. So what we wind up with here is no reaction. We always have to consult this activity series to decide whether this reaction, this single replacement reaction, is going to occur. Let's take a look at this next example. I've got zinc reacting with barium chloride, so I'm going to look up zinc. Here's zinc here, and zinc can only replace anything from its list here, so it's going to try to replace the barium. This is a cation reaction, or a cation replacement. Barium is up here. So my question is barium below zinc? The answer is no. So again, this will be no reaction. Because zinc is down here and barium is up here, zinc can only replace what's below it. Barium is not in the portion of the list below zinc, so zinc will not replace barium. Let's take a look at this next one. I've got barium reacting with zinc chloride. In this case, we just took a look at this. Barium's up here, zinc is down here. Zinc is below barium. Zinc will get replaced, so zinc is going to wind up on his own. and then we form barium chloride, which is going to be BaCl2. That BaCl2 is not because chlorine's a Hunkelbrief, it's because if we look up the ions here, I've got barium, which is here with a positive 2 charge. I've got chloride with a -1 charge. So we get Ba2 plus Cl minus. I need 2 of these to add up to 0, hence we get BaCl2. The next one, aluminum reacting with sulfuric acid. Aluminum is right here. Aluminum is going to try to replace, what's in the list? Hydrogen. There it is. So it's going to try to replace hydrogen. Sulfur's not in this list. Oxygen's not in this list. It's going to be it's going to be hydrogen. So I need to read this. Aluminum can only replace hydrogen in acids. Sulfuric acid is definitely an acid. Definitely an acid. So this reaction will occur. Aluminum will kick out the hydrogen. And you know what I usually, although it doesn't matter, you know what, I should just go ahead and do that. Aluminum sulfate, Al2SO43, is the compound that I make. And then hydrogen winds up on its own. It's going to be H2 because it's a Hunkelbrief. Again, that Al2SO43 is because of the charges. The other reaction, this next reaction, is aluminum trying to react with water. Aluminum can only replace hydrogen out of acids. This is water. This reaction is not going to occur. No reaction. RXN is an abbreviation for reaction in case you didn't see that before. Again, with single replacement reactions, I need to consult this list.